Section 2.7 is all about angle pair relationships. It's a continuation of the proof process, and this section gives us more theorems and definitions that we can use as reasons in our proofs. The first theorem, now remember, a theorem is something that can be proven as opposed to a postulate which cannot be proven. The first theorem is right angles congruence theorem. It states all right angles are congruent. To me, that kind of seems apparent, but again, we can prove this. So I've provided the proof of that. So if you look here, we have given that angle 1 and angle 2 are right angles, and we're supposed to prove that means that angle 1 is congruent to angle 2. So if you look at this proof, first they state that angle 1 and angle 2 are right angles because that was given. Then, using the definition of what a right angle is equal to 90 degrees. So we stated, because we know that angle 1 and angle 2 are right angles from the first step, we know that angle 1 is equal to 90 degrees and angle 2 is equal to 90 degrees. That's from the definition of a right angle. Next, if you notice, we have two angles equal to the same number. So the 90 degrees links angle 1 and angle 2 together, so that would be the transitive property. Angle 1 is equal to angle 2 because of the transitive property, and knowing that if the measures are equal, that means that they are congruent. So now that we know, we've stated that angle 1, the measure of angle 1 is equal to measure of angle 2, now we can state that angle 1 is congruent to angle 2, and that's due to the definition of what congruent angles are. Because they were equal, that means they're congruent. Thus, we have proven that if you know that two angles are right angles, they are congruent. Now we can use this, again, we can use this theorem as a reason in our proofs from now on. And example number 1 does just that. So first, it states that we just need to write a proof. So given line L is perpendicular to line M, and line L is also perpendicular to line N. We are supposed to prove that angle 1 is congruent to angle 2. So if you look at your diagram, they've marked on there for you, knowing that line L is perpendicular to line M from our given, they've marked angle 1 as a right angle. That's how you mark that something's perpendicular on a diagram. And line L is also perpendicular to line N, and they've marked angle 2 as a right angle. Because again, that's how you mark that two lines are perpendicular on a diagram. Now looking at the proof that's been started for you, you can see that they've started with the given information as step 1. Line L and line M are perpendicular, and line L and line N are perpendicular, and that was given. Step 2, angle 1 and angle 2 are blanks. Remember, we have to link all of this together. So looking back at the first step, we had our two pairs of perpendicular lines. What do we know, given that these lines are perpendicular, what do we know about angle 1 and angle 2? Well, we stated this earlier. We know that angle 1 and angle 2 are right angles because of the definition of what perpendicular means. So again, I know that angle 1 and angle 2 are right angles because I knew that the lines were perpendicular. So I'm going to use the definition of perpendicular lines to justify that. And notice how I'm going to abbreviate that. I'm just going to put def for definition of perpendicular. I'm going to use the sign lines. And you can do the same. You can abbreviate just like that, as long as the idea is still put across to me that you mean definition of perpendicular lines. Step 3, angle 1 is congruent to angle 2. We now know, using our theorem from the beginning of this section, that all right angles are congruent. So now that I've stated that angle 1 and angle 2 are right angles, I can now state that angle 1 is congruent to angle 2 and justify that using the theorem that we first stated when this video started, which that was called the right angle congruence theorem, and it stated all right angles are congruent. So my reason would be the right angle, notice how I'm going to abbreviate this, the right angle congruence theorem. If you want to write that all out, that's up to you. Otherwise, I will be perfectly happy if you just abbreviate it just like I did. This proof is now done because remember, my last step is to always state whatever the prove statement was. I was asked to prove that angle 1 is equal to angle 2, and I did that. To show that I'm done, I'm going to put my two lines. Next, we have two more theorems, and these two theorems are very closely related to each other. The first theorem is the congruent supplements theorem. It states if two angles are supplementary, meaning they add up to 90 degrees or form a straight line, to the same angle or to congruent angles, then they are also congruent. So if you look at this diagram, they give a nice example. If angle 1 and angle 2 are supplementary, so angle 1 and angle 2 are supplementary, and angle 3 and 2 are supplementary, so 2 and 3 are supplementary, then that must mean that angle 1 and angle 3 are congruent. So let me give you an example. Let's say that angle 1 is 20 degrees. Knowing that it's supplementary with angle 2, it would have to be 160 degrees, 180 minus 20. I also know that angle 2 and angle 3 are supplementary. So if angle 2 is 160 degrees, that means angle 3 would have to be 20. Therefore, you can see angle 1 and angle 3 have to be congruent. Congruent complements theorem is much the same. If two angles are complementary this time to the same angle or to congruent angles, then they are also congruent. So just like before, angle 4 and angle 5 are complementary. So angle 4, angle 5 complementary. And angle 6 and angle 5 are complementary. Then we know that angle 4 and angle 6 must be congruent. So kind of the same idea if I give you an example here. If angle 4 was 30 degrees and I know it's complementary to angle 5, that means angle 5 has to be 60 degrees. I also know that angle 5 and angle 6 are complementary. So if angle 5 is 60 degrees, then angle 6 has to be 30 degrees, thus showing that angle 4 and angle 6 must have been equal and congruent. So again, this is the congruent supplements theorem and the congruent complements theorem, and both of these theorems you can use now as reasons in your proofs. And example number 2 does just that. We're supposed to write a proof given that angle 1 and angle 3 are complements, so here's 1 and 3, and we also are told that angle 3 and angle 5 are complements, so here's 3 and 5. So we are supposed to now prove that angle 1 is congruent to angle 5. So we'll start our proof with stating our given. So we were given that angle 1 and angle 3 are complements and angle 3 and angle 5 are complements. I combined this just into one statement since they both had the same reason of being given. And we can actually just do a two-step proof here. Now that we know that angle 1 and angle 3 are complements and 3 and 5 are complements, we have angle 3 and angle 3 in both of those. So here we have two different angles complementary to the same angle, which is exactly what the congruent complements theorem states. So we can jump down and just say now angle 1 is congruent to angle 5 and justify it by saying the congruent complements theorem. So I'm going to abbreviate that as congruent complements theorem. And since we ended our proof with what we were given, because remember the last step in your proof should always be whatever that proof statement was, we can show that we are done with this by putting our two slashes. Next we have another postulate and another theorem that are going to be fair game to use as reasons in your proofs. The first one is a postulate, and we actually talked about this postulate last chapter when we defined what linear pairs are. So this is called the linear pair postulate. If two angles form a linear pair, so remember a linear pair are two angles that form a straight line, then they are supplementary. We know this because a line, so linear pair, a line is 180 degrees, and if I have two angles forming that line, then those two angles add up to 180 degrees, and by definition that means they are supplementary. So in our diagram it says angle 1 and angle 2 form a linear pair. You can see that since they form a straight line. So angle 1 and angle 2 are supplementary, meaning that the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. Again, we already know this because we talked about it in chapter 1, but now we're just formally calling this the linear pair postulate. Next, we have a theorem, which is called the vertical angles congruence theorem. It just simply states that vertical angles are congruent. And in the next slide, we're actually going to prove this theorem is true. But again, we know that if we have a pair of vertical angles, then we know those angles are congruent. So in the diagram, angle 1 and angle 3 are vertical angles, so we know that they are congruent. And angle 2 and angle 4 are vertical angles, so we know those are congruent. Now remember, just as a little refresher, vertical angles are formed by the same two intersecting lines, and they sit across from each other. So again, angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are vertical angles, and we know that those are congruent now. Example number 3, again, as I told you in the last slide, we are going to now prove that vertical angles are congruent. So we'll start the proof by stating that angle 5 and angle 7 are vertical angles. We know that just by looking at this diagram. And we are supposed to prove that angle 5 and angle 7 are now congruent. So I've kind of done a bit of the proof for you to walk you through this, and basically we're just going to be asked to fill in the reasons for each of the statements on the left-hand side. So step 1, angle 5 and angle 7 are vertical angles. We know that because we were given that. We also just know that because we know what vertical angles are. We know that vertical angles are formed by two intersecting lines and they sit across from each other. So again, we already knew that without even it being stated. Next, I have down that angle 5 and angle 6 are a linear pair, and angle 5 and angle 7 are a linear pair. So if you look at the diagram, angle 5 and angle 6 are a linear pair because they're forming this straight line, and angle 6 and angle 7 are a linear pair because they're forming this straight line. I know this because of the definition of what linear pairs are. So that's exactly my reason. The definition of linear pairs. Next, you see that I've stated that angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. We know this because we stated that they were linear pairs, and now we have a postulate that states that two angles that are linear pairs are also supplementary. So I know this. My reason for this step would be that linear pair postulate that we talked about in the previous slide. So linear pair postulate. And moving on to step 4, we're ready to actually make this proof official. Angle 5 is congruent to angle 7. Looking back at the previous step, we saw that angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. Do you see how 6 is in both of these? So we have two angles, 5 and 7, supplementary to the same angle, angle 6. So I know that angle 5 and angle 7 must be congruent since they are supplementary to the same angle, angle 6. Because of the congruent supplements theorem. So congruence supplements theorem, which remember stated two angles supplementary to the same angle are congruent. So now looking back, I was asked to prove that angle 5 is congruent to angle 7. I did just that. So now my proof is over. So I will do my 2 hash marks to show that it is done. And that's it for this section. I would definitely write down the theorems and the postulate that were stated in this section so that you have them in your notes ready to go for when you're doing your homework and or doing a quiz or a test, so you have them right there ready for you to look at. And remember, all of these theorems and all of these postulates are all fair game to use as justifications within your proofs. Just make sure that if you didn't understand anything in here that you ask about it in class so we can cover this before we move on. And we'll see you then.